Instant oceanic evaporation initiates the total phase transition of 1.3 billion cubic kilometers of liquid water into gaseous vapor. This physical failure disrupts the planetary hydrostatic balance, triggering a chain reaction of atmospheric overpressurization and thermal runaway. The primary mechanism to fail is the oceanic heat sink, which previously regulated 90% of the planet's surface energy. Within 1 millisecond, the removal of the oceanic mass reduces the surface pressure on the sea floor by up to 1,000 atmospheres, causing the immediate isostatic rebound of the Earth's crust and the simultaneous volcanic eruption of submarine rift zones. The atmosphere's volume expands exponentially as 1.4 sextillion kilograms of water vapor displace the existing nitrogen-oxygen mix. This expansion generates a supersonic global shockwave that levels every structure with a height-to-base ratio exceeding 1:5. A human standing at any elevation experiences immediate eardrum rupture as the ambient pressure triples within seconds. Simultaneously, the partial pressure of oxygen drops below the threshold for cellular respiration, while the air temperature rises to 200 degrees Celsius due to the latent heat release of the phase change, effectively flash-boiling the internal fluids of all biological organisms before the shockwave arrives. The removal of liquid mass terminates the centripetal stabilization of the planetary crust. The basaltic plates of the oceanic basins, no longer compressed by the weight of the water column, fracture and buckle upward. This sudden mass redistribution shifts the planetary axis of rotation by several degrees, altering the centrifugal force exerted on the atmosphere and land masses. The tectonic plates accelerate their drift, colliding with continental margins and triggering magnitude 11.0 seismic events globally. Molten rock from the mantle surges into the newly formed oceanic voids, accelerating the thermal transfer from the core to the surface and further increasing the kinetic energy of the atmospheric gases. The atmosphere transitions into a supercritical steam envelope. Water vapor acts as a high-density greenhouse gas, trapping 99% of outgoing long-wave radiation. This thermal inertia causes the surface temperature to climb toward 500 degrees Celsius, exceeding the melting point of lead. The salt previously dissolved in the oceans, approximately 50 quadrillion tons, solidifies into a crustal layer 60 meters thick across the former seafloor. These salt flats reflect solar radiation, creating a high albedo environment that intensifies the heat within the lower atmosphere, causing the remaining soil moisture to desorb and the lithosphere to crack into hexagonal fissures deep into the bedrock. Aerodynamic drag increases as the atmospheric density doubles, slowing the planet's rotation through tidal friction between the thick gas layer and the jagged oceanic mountain ranges now exposed to the wind. Constant cyclonic storms, driven by a 300-degree temperature differential between the sunlit and dark sides of the planet, reach wind speeds of 800 kilometers per hour. These winds carry abrasive salt crystals and volcanic ash, which sandblast the continental surfaces, eroding mountain ranges into dust within decades. The lack of a liquid water cycle prevents the sequestration of carbon dioxide, allowing the gas to accumulate until the atmospheric pressure stabilizes at levels similar to those found on the surface of Venus. The planet's magnetic field, generated by the geodynamo, weakens as the shifting crustal mass disrupts the flow of the liquid outer core. This reduction in electromagnetic shielding allows the solar wind to strip the upper layers of the steam atmosphere into space. Hydrogen atoms, being the lightest, escape the gravity well first, leaving behind a heavy oxygen-rich atmosphere that triggers the rapid oxidation of all surface minerals. Iron-rich rocks across the planet turn to rust, consuming the remaining free oxygen and solidifying the planetary surface into a sterile, red oxide desert. The lack of hydraulic lubrication between tectonic plates eventually grinds the movement of the continents to a halt, locking the planet into a state of tectonic stagnation. The final state is a high-pressure, high-temperature equilibrium. The energy previously stored in the chemical bonds of the oceans has been converted into thermal radiation and kinetic wind energy. The Earth exists as a dry, rocky sphere encased in a thick, toxic gas envelope consisting of carbon dioxide and sulfur. The hydrological cycle is replaced by a cycle of mineral sublimation and deposition. The planet's mass remains relatively constant, but its biological and chemical complexity has been reduced to zero. Gravity continues to hold the heavy atmosphere against the scorched crust, but the lack of a thermal sink ensures that the surface temperature remains high enough to prevent the reliquefaction of any gaseous water for millions of years.